Hello everyone. This is my final year project titled Secure Data Communication for Defense, undertaken at ITI Bangalore. So let's go ahead. In this project, we propose a video data embedding scheme in which the embedded signature data is reconstructed without knowing the original host video or audio file. Basically, in this project, we use the method known as LSB substitution, or least significant bit substitution. What we do is, in each component of each pixel, we substitute the least significant bit, thereby hiding ASCII values in the least significant bit. And also in this project we use another processing mechanism known as OPAP, or optimal pixel adjustment process. And this project enforces security by hiding message in the image, and also while retrieving the message you require the encryption key. Without the encryption key you will not be allowed to access you will not be allowed to retrieve the message. So let's look at the existing system. The existing system uses pixel value differencing method and other methods for data embedding in each of the component of a pixel in a color image. The pixel value in a stego image may exceed the range 0 to 255 on applying the PVD. This basically reduces the security in data transmission without detection. It may also lead to improper visualization of the stego image, which again makes it very easy to detect. The existing system offers very little in terms of security, as a given image can be intercepted by anyone. And also the existing system is also vulnerable while taking the difference between the size of the original file and the stego image into consideration. Now, the proposed system. In the proposed system, we propose a system that implements audio, video, and image steganography. The proposed system makes use of the least significant bit substitution method to encode data. In addition to the LSB method, we make use of the optimal pixel adjustment process, and this leads to enhance image quality and low computational complexity. Also, we propose a system that enhances security by using a security key, as mentioned before, and this method also provides an option to compress the file, thereby enabling the user to set the size of the output file to equal to the size of the original file. This is the system architecture, and this is the data flow. Well, as you can see in the data flow between the sender and the receiver, the input or the master file, which can be any image, is taken and it's put through the processing mechanism where you enter your secret text or the file to be embedded, and also you provide the secret key along with it. And once this is done, you can the message will be embedded into the master file, and then it can be sent over the network. And as you can see in the receiver side, the stego image is taken as input and processed, and along with the security key. The security key, the receiver must always know the security key to access, or to retrieve the message. And once it goes through the processing mechanism, again the output is the secret text or secret file that was hidden. This is the class diagram, the activity diagram for it. Okay, so basically this is a Java program developed in Java, so I've run it basically from the command prompt. And yeah, so this happens to be the main form. Just 1 second. So yeah, this is the main form, and as you can see, there is an option to embed a short message and also an option to retrieve short message, and there's also an option to embed multimedia files and retrieve the files. So let's start off with embedding a short message. When you click on the embedding a short message, you get this pop-up, what you need to do is select a master file. Any master file. And it takes you to this form where this is the master file. Sorry. So yeah, this is the master file and this is the output file. So there is an option, as you can see, for compressing, and this is the different ratio for compression, and this is for encryption. The encryption is done using a password, or minimum password of 8 characters is required. And this is the text editor where you can type in the secret message. Could be anything. Just type some secret message, and over here in this little text box you can type in your password. And once you click on go, you can see file has been, right now our message has been embedded successfully. And once this is done, what you can do is close this, and the receiver side you can again just press on retrieve message and select your master file, which would be the file that's been sent to you. And once you select the master file, this pop-up appears with the master file information, which shows the master file, the name of the master file, what it contains, whether it's an embedded message or an embedded file, whether it's compressed, the compression ratio, and whether it's encrypted, and also the request operation, which is right now retrieve message. So when you press on go, it obviously prompts for the password, and so when you type in the password, you click on retrieve now, and the file is retrieved, as you can see. This can also be done in multimedia files. So there's an option for hiding data in multimedia files. So let's click on embed file, and again if there's an option to hide an image inside another image. So let's select the master file, the output file. Now we need to select the data file, the data that you are going to hide within the master file, and let's see. It's the same process basically, and there Ubuntu has embedded successfully in the background. I haven't given the encryption password for this case, so should be easier. When I retrieve file, let me just select the master file and the details of the master file, name, whether what it contains. It's an embedded file, compressed 28%, encrypted no, and the request operation, which is retrieve file. Once you click on go, it asks you whether you'd like to open it now, and once you click on yes, there, this is the data file or the image file that was hidden within another image file, within another multimedia file. So yes, so basically this can be done for hiding data in video, or hiding data in audio, or anything like image in video or image in audio, stuff like that. So this is I'd like to conclude by saying that this is one of the most efficient ways for secure data communication, and is very useful for defense applications where security is the primary concern. Thank you.